All right, our last section is Radian trig equations level 2. So this one is a little bit different, slightly. And you can see that we're solving the trig equation for all values between 0 and pi over 3, which looks a little weirder, but you'll see why. And then in our equation that's given to us, it's sine of 6x is equal to 0. So that's totally fine. What we're going to do is we want to get the sine by itself, and the sine is already by itself. Okay, I don't know why it's lagging so badly. I did the zooming so long ago. Did you hear me say that? All I said was we just want to get the sine by itself, and right now the sine is already by itself because there's no like number here, there's nothing like added or subtracted at the end. So right now our sine is by itself, so that's good. And yeah, so it's okay. Let's switch colors. There we go. So remember that sine is equal to the y value. So we're going to be looking for a y value of 0 on the unit circle. Okay? So far it's pretty similar. We're just looking for a y value of 0 on the unit circle. So I'm going to zoom out. I think we did a problem just like this earlier. Here's a y value of 0. Here's a y value of 0. And so the radians that correspond with that are 0 radians and pi radians. Right? So far we have, I'm going to write it down over here. Our angle would be 0 radians. And then another angle would be pi radians. So we're not done yet, but we have noted that since sine is equal to 0, we found that that happens when our angle is 0 radians and pi radians. Here's what we do after this, is that since they gave us sine of 6 pi, this is our theta, okay? So instead of theta equals 0, you want to replace 6x equals 0. Did I say 6 pi earlier? I meant 6x. I don't know if I said 6 pi or 6x. I'm breathing in a lot of smoke. I'm sorry. The air is really smoky. So replace the theta with 6x is equal to pi. And 6x is equal to 0. So what we did here was we replaced what they gave us into our equations. And we're going to solve for x. Are there any questions up until here? All right, so then we just divide by 6 on both sides, or I guess on all of it, so that we can get x by itself. And then on the left side, the 6's cancel out. We will be left with x is equal to 0. Here's one answer. On the right side equation, we have the 6's cancel out. We get x is equal to pi over 6. Here will be our other answer. And so here are our two answers. And so zooming out a little bit, the reason why they restricted us to 0 all the way to pi over 3 is because originally your range is from 0 to 2 pi, but this is for 6x. Like they gave us 6x over here. So if we want to find x, we divide everything by 6. It's going to be 0 ranging all the way to 2 pi over 6, which is the same thing as pi over 3. So that's why the range over here, or I guess I should call it the domain, sorry. That's why it goes from 0 all the way to pi over 3, is because they gave us a 6 pi here instead of, sorry, a 6x instead of an x. I don't know why I keep saying pi. I am sorry. So yeah, our two answers are x is 0 and x is pi over 6. Let's go type those in, because I haven't seen a question show up, but if I typed it too fast, please let me know. So we got 0 and pi over 6. Okay, Let's do more of these. Oh, this one looks crazy. Don't worry, it's okay. So treat this as you would treat it like this. Maybe if this looks too complicated for you, just take this piece and turn it into a theta. And we'll just replace it later. So right now we have 2 cosine theta equals radical 3. And let's just solve for cosine theta. So we divide both sides by 2. I'm going to rewrite it on the side here. I'm going to rewrite it over here. We're going to get cosine theta is equal to radical 3 over 2. So we're going to look for, on the unit circle, remember cosine theta is the x value. So we're going to look for the x value of radical 3 over 2. Let's go on to our unit circle and find the x value where it's radical 3 over 2. X value, radical 3 over 2. X value, radical 3 over 2. Corresponding with pi over 6 and 11 pi over 6. Before we go on, any questions so far? Okay, so we have that our theta, our angles are equal to pi over 6. And then another one is 11 pi over 6. Okay, I'm going to zoom back in here. So remember how we replaced 2 pi over 7x with theta? Now we're going to replace that back in here. So 2 over 7x. Did I say pi again? Oh my gosh. What is wrong with me? 2 over 7x is equal to 11 pi over 6. Okay, so we replaced earlier this 2 over 7x with theta. So now we are replacing our thetas with 2 over 7x, just kind of replacing it back in there. Because theta was our placeholder. And so now we're just taking it away and replacing it with the original. Okay, so let me find myself some more space by, I guess, just zooming in more like that. I guess that's more space. We're going to solve for x. And so to solve for x, we can multiply both sides by, let's do it by dividing both sides by 2 over 7. Okay, so the 2 over 7 being multiplied to x can cancel that. And then we will have x is equal to pi over 6. I'm just going to write it as divided by 2 over 7 for now. And on this side, x will be equal to 11 pi over 6 divided by 2 over 7 for now. And when you're dividing by a fraction, remember that's the same thing as multiplying by a reciprocal. So I'm going to change that to multiplying by 7 over 2. So instead of dividing by 2 over 7, we are multiplying by 7 over 2, because when you divide by a fraction, that's the same thing as multiplying by its reciprocal. And then we're going to solve this. So we have 7 times pi on the top. Should I write in black? Would that be better? I'm not sure if that's better or worse. 7 pi over 6 times 2 is 12. I'll write it over here. And then here we have 7 times 11 pi. I'll just call it 77 pi over 6 times 2 is 12. So we got 7 pi over 12 and 77 pi over 12. All right, any questions on this one? So these would be our answers, by the way. 7 pi over 12, 77 pi over 12. As weird as those look, those would be our answers. And to give you guys time to think about questions, I'll pause the recording. All right, so 7 pi over 12, 77 pi over 12. Let me hopefully remember that. 7 pi over 12, 77 pi over 12. Okay, cool. So let's do one more, and then that will be it for this section. Because I assume if you didn't need the other example, you're probably already working anyways, so it's totally fine that I do another one. So we have this crazy looking tangent. And so remember, if this thing looks like far too crazy for you, just replace this with theta. So we have tangent theta minus radical 3 equals 0. And so let's get the tangent theta by itself. So what we can do is add radical 3 to both sides. And we'll just get tangent theta is equal to radical 3. And so remember that tangents are the y over x on the unit circle. And so you have to think to yourself, where can I get a y divided by x to equal a radical 3? And so this can happen if you remember that radical 3 is the same thing as radical 3 over 1, and that this is the same fraction as radical 3 over 2 over 1 over 2. And then now, this is one of the things you can find on your unit circle, where your y is radical 3 over 2 because the y is on top, and the x is positive 1/2 because the x's and the 1/2 are on the bottom. There's another one that you can find. So we have y over x can also be the negative radical 3 over 2 over the negative 1/2. So this can also give you positive radical 3 when you divide it, because a negative divided by a negative will give you a positive. So I know tangents and cotangents are hard because you just have to ask yourself, how can I manipulate these numbers until they look like something on the unit circle? So I know it is hard, but you just have to continue practicing until you get them down. So we have a radical 3 over 2 for the y and a 1/2 for the x. Let's go look for those on the unit circle. I'm going to highlight these in yellow, I guess. So for this one, I find that the y and the x, that's right here. And then let's see for the negatives, this one, where the y is negative radical 3 over 2 and the x is negative 1/2, I find that over here. Okay, so now that I found them, we know that the radians that go with it are 4 pi over 3 and pi over 3. Now before I go on, I'm going to pause it and see if you guys have any questions. So we have, I'm just going to draw a line here to separate out the stuff. We have that our theta is equal to pi over 3. And we have another one, theta is equal to 4 pi over 3. Okay, I'm just going to zoom in now, if it will let me. There we go. And remember, we replaced theta with, or we replaced this whole thing with theta, so I'm going to now replace theta with 3 pi over 5x. And the same thing over here, 3 pi over 5x. Okay, so that's one crazy looking fraction, but we're going to treat it the same way we did earlier by dividing it out. Divide by 3 pi over 5. Divide by 3 pi over 5. Okay, and so when you are dividing by a fraction, actually, let me just write it out first. We have pi over 3 divided by 3 pi over 5. This one we got x is equal to 4 pi over 3 divided by 3 pi over 5. Okay, now I can say when you are dividing by a fraction, we are now going to multiply by the reciprocal. So we're going to multiply it by the flipped version. So we're going to multiply it by, instead of 3 pi over 5, I'm going to do 5 over 3 pi. Same thing over here. Instead of dividing by 3 pi over 5, I'm going to multiply it by the reciprocal. So flip 5 over 3 pi. Okay, so now that we've flipped it and switched it to multiplication, you can multiply straight across. So we have 5 times pi on the top, that's 5 pi. And then we have 3 times 3 pi, that's 9 pi on the bottom. And for this one, we have 4 pi times 5 on the top, that's 20 pi on the top. And 3 times 3 pi on the bottom, that's 9 pi. And then the pi's can cancel out. You could have canceled the pi's earlier, that's totally fine. I just didn't until now. So once the pi's cancel out, you will be left with 5 over 9 on this one. And on this one, you'll be left with 20 over 9. So those would be your answers, 20 over 9 and 5 over 9. Any questions now on this one? All right, so let's enter 5 over 9, 20 over 9. 5 over 9, 20 over 9. Okay, so that was 3 examples of each of those. So yeah, let me know if you have any questions by calling me over to your breakout rooms.